Thank you, Peter, and good morning, everybody. Well, this presentation provides information on work that was done by RWDI consultants, and it builds on the work that you've just seen presented by Conrad. The work essentially utilizes the emission results from the 8 scenarios. Actually, we're going to distill that down to a subset of that, 3 scenarios, as inputs to a regional air quality model, which will predict the ambient air quality outcome of those emissions. So to start, I want to quickly explain that the complex relationship between emissions and air quality. The key thing to remember is that emissions do not equal air quality. Air quality is a function of the interaction between the emissions themselves and then various influences related to meteorology, topography, and other influences. So if we look at the oval on the left-hand side, we have emissions of nitrogen oxides, VOCs, volatile organic compounds, particulate matter, sulfur oxides, and ammonia. And these originate from industrial stacks, vehicle tailpipes, chimneys, all sorts of different emission sources, both within the region and transported from outside the region. And I'll refer to these in this presentation as precursor emissions because these emissions react in the atmosphere. They go through a series of chemical reactions in the atmosphere. Some of them are consumed, and they can form ground-level ozone, secondary fine particulate, and this in turn leads to smog and haze and impairment of visibility and potentially to health impacts. So what we've tasked Metro Vancouver keeps track of both sides of this equation. An emission inventory, which is basically a bookkeeping of all of the different sources of emissions in the airshed, and the operation of a comprehensive network of monitoring stations, 27 stations located from Horseshoe Bay to Hope, which keep tabs on the outdoor air quality, measure the concentrations that people are exposed to relative to a series of objectives and standards which have been established by the provincial and federal governments. So what our consultants have been tasked to do is to apply an air quality or an airshed model to predict the relationship between the left-hand and the right-hand side of these two ovals, to predict the outdoor air quality based on the emissions that are discharged to the atmosphere. So these pie charts show the emissions context for our region. Just to quickly go over this in the interest of time, we can see that waste management is a small contributor to NOx emissions, 0.8% of the total NOx emissions in 2005, the year of our most recent emission inventory, and about 0.3% of total PM 2.5, which is fine particulate. And I haven't shown the pies here, but it'd be 1% of SOx, 0.1% of volatile organic compounds, and 0.3% of ammonia. And we can see on this chart also that there are a number of other significant slices of the pie, largely related to light-duty vehicles, heavy-duty vehicles, marine sources, non-road engines, buildings and heating and burning and other sources like that. So certainly those are significant sources and then being dealt with other aspects of the air quality management program in the region. Our emission inventory also includes forecasts of emission trends on a 25-year horizon. And these forecasts are based on the best available information with respect to population growth, economic trends, projected changes in vehicle use, as well as vehicle tailpipe standards and fuel quality. We can see in this one that the emissions of some contaminants have decreased or leveled off. If we look at the period from 1990 to 2005, we can see that the VOC and NOx compounds have decreased fairly significantly from the 1990 period, and this is largely related to improvements in tailpipe emission standards. Fine particulate matter has been fairly steady over the period of record, but there are precursor emissions which are forecast to increase. Looking at the blue line on the bottom, we can see sulfur oxides. These have shown a significant improvement from the 1990 period, and this is largely related to increasing stringency of regulations that govern the sulfur content of fuel. But that's mostly related to land-based fuels, to on-road fuels and home heating fuels. The forecast that's predicted in the future for sulfur oxides reflects projected increases, expansion of port activity, and with increasing use of marine vessels and the higher sulfur content of fuel that they use, we expect the sulfur oxide emissions to increase in the future. And then ammonia, the red line above that, is basically largely related to agricultural activity. So with growth in agricultural activity, we also expect growth in ammonia emissions. So this chart shows the emissions from solid waste management scenarios, and these are the 3 scenarios that Conrad had showed you earlier: the large new waste-to-energy plant, the local landfilling of an MBT product, and out-of-region landfilling. So we can see that the emissions from waste management, this chart actually shows the percent contribution to total emissions in the airshed. So emissions from waste management are a small contributor to the airshed totals in the year 2020. We can see on the left there that although there is variability in between the scenarios, the SOx emissions do not account for any more than about 1% of the total loading in the airshed. And looking at the PM 2.5 on the right, we're looking at about 0.1% of total emissions. And you'll recall the pie charts that I showed earlier that showed that there was a similar small contribution in 2005. These blue lines actually represent the pie slices that I showed you for 2005. So this is the percent contribution in those blue lines in 2005. So the 2020 scenarios are actually going to be less than or comparable to present-day contributions to emissions loading. And one last thing to note here is that the 2020 future emission scenarios, these are not new or incremental emissions. They are, in fact, replacements of the 2005 emission levels.